Good morning, everyone, especially to my lecturer, Dr. Sairul. Today, I want to present about the week at algorithm architecture presentation, which is related with my project, academia classification using Covnex. Before we before I start the presentation, let me introduce myself. My name is Salah Sanalai. The student ID is 5721 4225 146. This presentation focuses on apply the deep learning to ECG signal for automatic the Hertz rhythm detection. As you can see in this slide, this is the model architecture explanation. My input data comes from the MIT BIH Actimania dataset, which is the content of ECG signal with natural noise and variability between patients. Then, to prepare the data, I apply the bandpass filtering between 0.5 and 40 Hz to remove the noise, segment the signal using RPEG detection, normalize the amplitude for consistency, and label them into the class such as normal, PVC, and AF. Finally, the ECG signals are converted into the spectrogram image using STFT and assigned to 224 by 224 pixels for Comnex input. As you can see in this slide, this is the another model architecture explanation from my project. The Comnex architecture automatically extract the picture through the convolution blocks with large kernels, layer normalizations, and glue activations. As you can see in this slide also, this is the final layers, which is a global pooling, fully connected layers, and soft max activations. So the input is this produce a multi-class classification output for the normal, AF, and PVC academias. As you can see in this slide, this is the reason why I chosen this model is suitable to my project. I choose Comnex because it eliminated the needs for manual feature extractions. It learns complex the ECG patterns automatically, even in noise biomedical signal. Compared to the traditional methods like SBM and KNN, Covnex achieves the higher accuracy and better generalization across the different patients. It is also well suited for image-based spectrogram input and is inspired by modern transformer architectures. As you can see in this slide, it is the loss function to my project. I will explain about the loss functions. The loss function used is cross entropy loss, which is ideal for multi-class classifications. It compares predicted probabilities with actual labels and update model weight during the training. Together with the softmax output, this ensures effective learning and improved accuracy. As you can see in this slide, this is the training strategies for my projects. Firstly, my dataset is split into 70% trainings, 50% validations, and 50% is testing. Training is conducted with a learning rate of 0.001, batch size is of 16 or 32, and 30 to 50 epochs. Validation helps the monitor's performance and prevent the overfittings. As you can see in this slide, this is another explanation the training strategies for this project. The testing dataset evaluates the final model performance. I use the metrics such as the accuracy, precision, recall, and F1 score. Additional tools include the conversion metrics such as RC curve and AUC to provide the deeper insight into the classification reliability. As you can see in this slide, this is the conclusion for my project, which is the presentation today. This project successfully demonstrated the use of the Comnex deep learning model for automatic actimania classification using the ECG signals. The system is able to process the raw of ECG data to the pre-processing and convert it into the spectrogram image for effective feature learnings. Convex show strong performance in capturing complex and subtle the patterns in ECG signals compared to the traditional machines learning methods. The use of cross-entropy loss and the optimize have improved model accuracy and training efficiency. The training strategy, which is including the proper data splitting and validation to ensure that the model can generalize well to unseen data. Finally, the proposed approach provides a reliable and scalable solution for automate heart disease detection. This system has strong potential for real-time healthcare application and can assist clinical in early diagnosis and decision making. That's all for my presentation today. Thank you for watching this video until the end, and also thank you for your attention.